Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rogini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. Now I am going to discuss about the topic on Delta Modulation Receiver. So on completion, the Delta Modulation Receiver, the students will be able to define the receiver technique for Delta Modulation, draw the block diagram of Delta Modulation Receiver. So first, what is meant by delta modulation? So the delta modulation, this is the type of modulation where the sampling rate is much higher and in which the step size, this will be after the quantization of the smaller value delta. So such the modulation is termed as delta modulation. So the delta modulation, this is a simplified form of differential pulse code modulation technique, and also this can be viewed as one bit the differential pulse code modulation scheme. As the sampling interval is reduced, the signal correlation will be higher. The sampling rate of the signal should be higher than the Nyquist rate. So we have to achieve the better sampling. So here we are going to see about the delta modulation receiver. So in that receiver block, this will be consist of accumulator and a decoder and low pass filter and high pass filter, and this is also called as reconstruction filter. So the accumulator is used to generate the appropriate staircase with one delay, that is T. This is the diagram for the delta modulator receiver. First we are having the delta modulation signal. This will be connected to the decoder and this will be connected to the summer, and this is connected to the low pass filter. So in the down we are having the delay, that is TS. So this is the accumulator circuit. Finally we will get the reconstructed message signal, that is M of NTS. The summer will be at the quantizer output with plus or minus del. So the previous sample approximation is U of NTS will be equal to U of N minus 1 TS plus or minus del. So the U of NTS will be equal to U of N minus 1 TS plus B of NTS, where the B of NTS will be equal to plus or minus del. So then the accumulator, if the input is binary 1, the plus del step is added with the previous output. So the low pass filter is mainly used to reconstruct the original signal, that is M of NTS. So this is the waveform for the delta modulation. So in that thing we are having the staircase approximation, that is M cap of T. Then we have to calculate the SNR for the delta modulation, that is signal to noise ratio. So how we are calculating the signal to noise ratio in delta modulation, that is the amplitude of the modulator output will be changes by plus or minus del only. So the maximum amplitude is AM, that will be equal to del Fs divided by 2 pi Fm, where there is no slope overload distortion, where the AM is the peak amplitude of the message signal. So where del will be equal to step size and Fm will be equal to message signal frequencies and Ts will be equal to sampling period. So the AM will be equal to del into Fs divided by 2 pi Fm. So here we have to calculate the SNR, that will be equal to SB divided by NP, where SP is equal to signal power and NP will be equal to output noise power. So where Ts is the sampling period. To find signal power, the signal power is given as P will be equal to V square divided by 2R, where V is the RMS value of the signal. Substitute V equal to AM divided by root 2, then we will get P will be equal to AM square divided by 2, where the resistance R will be equal to 1, just we have to assume. So substitute the equation 10 in equation 12. So the signal power SP will be equal to del square Fs square divided by 8 pi square Fm square. The quiz question is based on delta modulation receiver is in delta modulation, the slope overload distortion can be reduced by dash. Thank you.